So this is part 3 of the video series on problems on factorization. In this part, we have to factorize algebraic expressions like we did in our earlier problems. And these are the 4 identities on which these problems are based. So I have written it here so that we can quickly relate to the identities and we don't have to recall it every time. The first one is 4p squared minus 9q squared. Now this 4p squared can be written as 2p whole squared minus 9q squared can be written as 3q whole squared. Okay, now if we take 2p as a and 3q as b, then it is of the form a squared minus b squared. That is this identity. A squared minus b squared is equal to what? A plus b multiplied by a minus b. So this is a plus b multiplied by a minus b. What's a? In this case, we have taken a as 2p plus 3q. And what's this one? So this is 2p minus 3q. So this is the factorization of this algebraic expression 4p squared minus 9q squared. Here you have 63a squared minus 112b squared. Okay. Now here is one thing that again it should remind you of this algebraic identity, but you have to take out one common factor. Only after that you can use this identity. How? This is 63a squared. This can be written as 7 times 9 a squared multiplied by a squared. Why? 7 times 9 is 63 minus this can be written as 7 times 16 multiplied by b squared. Right? Now this 7 in this term and this 7 in this term of this algebraic expression, this is the common factor in both of these two terms. Take this 7 out common, and then inside the bracket you will have 9a squared minus 16b squared. Now if you're wondering that why did we do this, why did we take out 7, I'll explain you. Now this is 7 and this is 9a squared minus 16b squared. So 9a squared can be written as 3a whole squared, and this 16b squared can be written as 4b whole squared. Okay. Now, if you see here, we have made it 3a squared and 4b squared. Had you not taken out this 7, if you had not taken out this 7, then you could not make this square terms within this algebraic expression. Like this is 63a squared. You cannot form this in the form of a squared. Right? Sorry, you cannot write it in this form. That is something x squared. A can be written as a multiplied by a, but what about 63? 8 times 8 is 64. So you cannot write this as 8 times 8 64, 7 times 7 is 49. Okay, there is no square root of 63. That's why we took out 7, the common factor, out. So from this one, now if you take 3a as x, if you take 3a as x, and if you take this 4b as y, then this is 7x squared minus y squared. This should remind you of, this you can relate with this identity, that is a squared minus b squared, that is equal to a plus b multiplied by a minus b. So from this identity, you can write this as 7 multiplied by x plus y multiplied by x minus y. So this is 7. What's x? X is 3a plus what's y? Y is 4b multiplied by x means 3a minus y means 4b. So 7 multiplied by 3a plus 4b multiplied by 3a minus 4b. This is the factorization of this algebraic expression. 49 squared minus 36. So this is very easy. This 49x squared can be written as 7x whole squared. because 7 times 7 is 49 and x multiplied by x is x squared minus 6x squared. Now if you take 7x as a, 6 as b, then it is of the form a squared minus b squared. So again, this algebraic identity, this is a plus b multiplied by a minus b. A is 7x, b is 6, again a is 7x and b is 6. So this is the factorization of this algebraic expression. In this algebraic expression, we have 16x raised to power of 5 minus 144x raised to power of 3. Okay. If we write this as 16x raised to power of 3 multiplied by x raised to power of 2, right? We can write this like this, then minus sign, this minus. This can be written as 16 multiplied by 9x raised to power of 3. And why have we done this? We have done this to find out the common factors in these two terms so that we can take that out, right? The concept of common factors. You have to remember this. Common factors. So now 16 is here, 16 is here, x cubed is here and x cubed is here. So take out 16x cubed, the common factor outside the bracket, and within the bracket you will have x squared, this one, minus this 9. Now this is x squared minus 9. This is basically what? 16x cubed, x squared minus 3 squared. It is of the form a squared minus b squared, that is this one. And therefore this will be equal to 16x cubed, x plus 3 multiplied by x minus 3. So this is the required factorization of this algebraic expression. Here you have L plus m whole squared minus L minus m whole squared. Okay. So this is, if we take L plus m as A and L minus m as B, so this is of the form A squared minus B squared. What is A squared minus B squared? That is this identity. Therefore this is equal to A plus B multiplied by A minus B. So what's A? A is L plus m, then plus. What's B? B is L minus m. What's A? A is L plus m minus. What's B? B is L minus m. But you have to remember one thing. Now here actually you have negative sign. So first put this within the bracket, L minus m, because we have negative. Now you can open the bracket. So L plus m plus L minus m, and this is L plus m minus L plus m, right? Now plus m and minus m 0, plus L and minus L 0. You have 2L and multiplied by you have 2m. Therefore this is 4lm. This is the required factorization of this algebraic expression. 9x squared y squared minus 16. Okay, so this can be written as 3xy whole squared. Why? Because a, b, c raised to power of n is equal to a raised to power of n, b raised to power of n multiplied by c raised to power of n. The laws of exponents we have applied here. So 3xy whole squared minus 4 squared. Now if you take this 3xy as a and this 4 as b, this is of the form a squared minus b squared, and this should remind you of this identity, that is a plus b multiplied by a minus b. Therefore if a is 3xy plus b is 4, this is 3xy plus 4 and 3xy minus 4. This is your required factorization of this algebraic expression. It's x squared minus 2xy plus y squared minus z squared. So if you look at this one carefully, if you look at this one carefully, it's actually of the form a squared minus 2ab plus b squared, right? A squared, that is x squared, minus 2ab, that is minus 2x, and y, because that is functioning as b, plus y squared. So this is a minus, sorry, this is x minus y whole squared, this identity. Now this is minus z squared. Now if we take x minus y as L, if we take x minus y as L, then this is basically what? This is L squared minus z squared. It's of the form a squared minus b squared. So this will be equal to L plus z multiplied by L minus c. What's L? L is x minus y plus z now. What's L? L is x minus y and minus z. So this is your factorization of this algebraic expression. 25a squared minus 4b squared plus 28bc minus 49c squared. Okay, you can do one thing to solve this. Look at this carefully, right? Look at this one carefully, and if you do one thing, that write this 25a squared as it is, then take this minus, right? If you take this minus, and then within the bracket, this will become 4b squared. Now since you have taken minus outside the bracket, this will be minus 28bc, and this will become plus 49c squared if we put this complete in the bracket, because when you open the bracket, this will be minus 4b squared plus 28bc and minus 49c squared, right? Okay, now this is 25a squared minus, within the bracket, this is 4b squared, so 2b whole squared, right? And this is 49c squared, so 7c whole squared, minus 2 multiplied by 7c, sorry, 2b multiplied by 7c. 2 times 2 is 4, times 7 is 28, and bc. That is why, now if you look at this one carefully, it's of the form, if you take this one as 2b as x, then this is x squared, 7c as y, then this is y squared, right? Sorry, here we should have plus. This is not minus, this is plus, and this is minus 2xy, because we have taken 7c as y and 2b as x, right? So x squared minus 2xy plus y squared should remind you of this algebraic expression. So this is what? X minus y whole squared. What's x in this case? We have taken it as 2b. And what's y? Y we have taken as 7c. So this is 2b minus 7c whole squared. So this is your factorization of this algebraic expression. Sorry, now still you have 25a squared. I'm sorry, still you have 25a squared. This is only of this algebraic expression. So now you have 25a squared minus 2b minus 7c whole squared, right? Now this 25a squared can be written as 5a squared, 5a whole squared, then this is minus 2b minus 7c whole squared, right? Okay, now if we take 5a as L and 2b minus 7c as M, then this becomes L squared minus M squared, and L squared minus M squared should remind you of this identity. Therefore this becomes L plus M multiplied by L minus M. What's L here? L is 5a. What's M here? M is 2b minus 7c. right? Then multiplied by, let me copy this here. Then what's L? L is again 5a. Now here you have to pay attention. Now here it is minus sign, so this minus, and this is M. M is 2b minus 7c, so 2b minus 7c. Whenever you have negative sign, you have to pay attention. So this becomes 5a plus 2b minus 7c multiplied by 5a minus 2b and plus 7c. This is your factorization of this algebraic expression, this whole, right? And why this is the final factorization? Because it cannot be further broken down in its factor form. This is a irreducible factor form of this one, right? So this was about the factorization of this algebraic expression.